All right, it just started. So welcome everyone. Bienvenue tout le monde. This is going to be in English, but I'm going to make another video to translate it. So I'm really happy to welcome again Tommo Littlewood on this YouTube channel. So welcome, Tommo. How are you?
Bonsoir.
Bonsoir again. So we're going to talk again about one of the stress hormones. Maybe it's going to surprise a few people, but we are going to talk about nitric oxide. Can you tell us why maybe the first step, why you think it's part of the stress system, and then maybe talk a little bit about there's a good side when you look in the literature, you look at, for example, in the endurance sports realm, and people are taking beetroot juice and things like this, and they want to boost the nitric oxide. Maybe like talking a little bit about this, a few things that we may consider good, are they really good or not, and then switch to whatever you want about this subject. That would be amazing.
Okay, sure. I wouldn't say I'm a total expert on nitric oxide, but I do kind of have a perception of it from a kind of stress physiology perspective. It's classically, we need to think about it as more of a kind of a signaling molecule, more like a neurotransmitter. What's really different about nitric oxide is potentially it's a gas, and it's derived from L-arginine. So it's quite unique in a way, because you don't get many other transmitters that are kind of in this kind of gaseous domain, rather that you usually see kind of steroid signaling molecules. We see thyroid from tyrosine, but nitric oxide is one of these things that it's a bit like estrogen to a degree, right? It's like you need a certain amount of it. It's there and it's part of normal physiology, but to the extent that the stress pathway tends to activate it very, very easily. So we can some studies have suggested that when we have adequate levels of carbon dioxide, we get a low level of nitric oxide being produced. And when you're hypercapnic and there's lots of carbon dioxide and perhaps more acidic, I would more go onto the side of being more acidic than more carbon dioxide, but because it depends how you're looking at some of the studies, then we tend to see a lot more nitric oxide being produced. And in some studies that show that when it's hypocapnic and low carbon dioxide, there's not much being produced at all. There's more being produced. I'll clarify that again. In hypercapnia, we tend to see an elevated amount. In hypocapnia, we tend to see not much being produced. And I think that tends to make sense to a degree. But then we start to look at some of the other mechanisms about why nitric oxide is being produced, and we can start to say, well, it seems to be a problem as soon as this stress pathway is activated. And there are a number of instances like hypoxia, where we'll produce a lot of nitric oxide. I mean, there are various forms. For example, we have the MNOS, which is we have the enzymes that produce it, which are the synthases, but we tend to have the endothelial, which is our kind of vascular, arterial forms of nitric oxide. It's called endothelial nitric oxide. We have the neuron nitric oxide, which is classically for our central nervous system. And obviously we have the mitochondrial nitric oxide as well. And so these all tend to be produced in different schema. Now, if we look at end range of physiology, and we talked about, I think in one of the talks just a minute ago, about how in sepsis we produce vast amounts of nitric oxide. And also in hypoxia, we stimulate the production of nitric oxide. In hypothyroidism, we will produce more nitric oxide. Why? Because it's a vasodilator. And when we have a large amount of stress, when blood pressure is being increased, we're going to talk about aldosterone at some point, and aldosterone will increase the vascular resistance and increase the blood pressure. And so we tend to see nitric oxide being produced to act as a vasodilator, to take away some of the pressure. And to a degree, we can't really talk about this in isolation from everything else. When we understand the relationship between aldosterone and parathyroid hormone and in calcium, and how calcification of arteries causes problems that makes them less flexible, we will understand why we start to produce more nitric oxide. Because if we have a less flexible kind of calcified artery, and perhaps we can talk about cholesterol at some other point, but it's generally not cholesterol that causes heart disease. It's generally the calcification of the arteries and the lack of flexibility that causes for the need for cholesterol to be sent there. And that's why statins, for example, I'm digressing slightly, statins can lower cholesterol, but they rapidly increase the amount of calcification that occurs in the arteries. So a net effect of taking statins is increasing the amount of heart disease, but just lowering the cholesterol. But go figure, it's touted as being cardiac protective. But I'm digressing slightly. But what we can see is this relative state of stress. When we start to see, say, a loss of the redox mechanisms, which is where we have our enzymes NAD and NADH, we have optimal production of energy. And this is kind of going on with this reduction to NADH and then oxidation to produce NADA again. And when we lose that through whatever means, whether it's kind of autoglucose signaling from the pancreas, we have various kind of transporters like the GLUT transporters, like GLUT2. When we start to see kind of degradation to this kind of signaling and function, we let's see less insulin being produced. We see more sugar in our bloods, and the ability to utilize glucose is substantially decreased because there's not enough thyroid hormone, there's not enough pancreatic signaling, and so we can start to see relative states of hypoxia being induced from this. So, for example, nitric oxide can be produced in a low oxygen state. Why? Because we know we need oxygen to create oxygenated tissues, and therefore we'll get tissues that can be affected by this. But in the glucose example, we tend to, when there's a high amount of glucose, we tend to activate something called the polyol pathway. And what should happen is glucose should be converted to sorbitol, and then sorbitol to fructose. Now, often this system gets backed up, but because this pathway promotes reductive metabolism, we don't get the oxidation going on. This is a relative state of hypoxia that we tend to see in diabetes, and this is a classic sign when we see nitric oxide being produced. So yes, nitric oxide is certainly a useful signaling molecule that is useful for signaling, for neurotransmission, for vasodilation, but to the extent that it's easily triggered within this disease pathway makes it a problematic compound. And there are many studies where they've shown where they've inhibited nitric oxide and the enzymes nitric oxide synthase, whether it's the endothelial form in eNOS or whether it's the mitochondrial form. When it's inhibited, it tends to have a better outcome. And another reason because of that is because nitric oxide will break down the aerobic system. We talked about how methylene blue can be very, very good at restoring by accepting and donating electrons. Now, if cytochrome C oxidase is lost, for example, this is where something like methylene blue, or specifically something that inhibits nitric oxide, will actually restore the aerobic mechanism, so we start having optimal metabolism again. So we don't get stuck in this kind of chronic reductive metabolism over time. And nitric oxide can be part of that because it will break down aerobic metabolism to a degree, act like an uncoupler, because you will need to uncouple because you can't use that complex 4 of the aerobic pathway. Therefore, you don't have adequate ATP being produced. You don't have adequate carbon dioxide being produced. When you don't have enough carbon dioxide being produced, that affects the dissociation of oxygen from hemoglobin. So you can understand why then this kind of hypoxic state will then start to increase more nitric oxide as a stress response. Now, there are plenty of other reasons why that becomes a problem. So, for example, in cancer, nitric oxide is shown to be elevated. And nitric oxide can also stimulate, because it's a vasodilator, there's a significant implication between its ability to upregulate something called VEGF, which is our vascular endothelial growth factor. And when we start to see this being upregulated, this is when we start to see problems. If there's a cancer there, we have increased angiogenesis, and then we have increased proliferation that can go somewhere and metastasize. So yes, it is important to understand that perhaps on a low level, nitric oxide is being produced, but to the extent that the stress response is kind of perpetuating that stress response, breaking down the aerobic system. And, when we get stuck in the stress response as well, the ability to then convert nitrates and nitrates from our foods, say from preservatives in meats, bacons, salamis, this kind of thing, that can increase the amount of something called perioxynitrate. and that creates more nitrogen reactive species, which kind of have a similar effect to our reactive oxygen species that break down aerobic metabolism as well. So it's really kind of getting a head around that. You see a lot of people saying, yeah, nitric oxide is amazing, we need to create more. Go and have some laughing gas, or go and have some beetroot juice. And yes, it does increase vasodilation, but to the extent that your ability to kind of relax cardiovascular tissues might be a product of not having enough carbon dioxide available, not having enough glucose available, not being to efficiently oxidate, create enough oxygen being used. And another key, sorry, it's late, getting tired. Another key driver of that is low thyroid function, and hypothyroidism creates hypoxia. It will increase the amount of nitric oxide being produced, to the extent our aerobic metabolism is being degraded, not being used efficiently, to the extent we get inhibition of aerobic metabolism, push towards glycolysis. We'll have that perpetuation of lactate. Lactate increases in acidity, increases hypoxia. We need to produce more nitric oxide, and this is where the cycle just becomes aberrant and vicious, and to the extent that someone can succumb from that over time.
The incredible thing you mentioned here is that basically, again, you cannot take one thing and take it out of context and say, okay, you take this beetroot juice and you have this study design, and of course it shows an increase in performance. So, but if you compare it maybe to someone who would take an adequate amount of that would have an adequate amount of glucose available and would have no problem using it correctly and would produce also enough carbon dioxide, the result would be much less impressive than just taking water. So yeah, there's also this thing. And if the person is, if we imagine a lot of endurance type exercise and at a competition level, maybe a few things are going to be functioning, but not as good as someone who would have not pushed the machinery so far that maybe the nitric oxide in the end is going to help for the performance, but what is the cost? And the cost is you need to understand this within the whole thing about physiology, and the fact that whenever you go away from oxidative metabolism, things tend to get worse. And so how would you explain to someone the link between the fact that for some reason right now there's a sort of deification of lactate, and everyone thinks carbon dioxide is the bad guy. I'm just exaggerating a little bit. How can you help people to understand at least an alternative view, and maybe how can you put this back in the general context, which is how you use energy, how you produce energy, and why there's there's nitric oxide on one side for the vasodilation effect, but why don't we talk about carbon dioxide? Because it's so obvious that it's going to help with vasodilation, but we talk a lot less about this because it's not it's almost like the main vasodilator should be nitric oxide, when depending on what you read. Even if in the literature, you go on PubMed, you see nitric oxide, and it's not, it's part of the stress system, and it may indicate something that is problematic in the energy production or something. It's good, it's going to vasodilate. That's what we want, because we don't want high blood pressure, and basically that's it. How can you help people to recover from this reductionist perspective, if I may say?
Yeah, I think there's a couple of things there. I think one thing that's really interesting, you talk about, say, endurance exercise. I don't know what I haven't looked at the studies of beetroot juice because it doesn't interest me. Too many important things to look at. But if we look at, say, the effects of caffeine, which we know has a temporary blood pressure increasing effect, but yet does some amazing things to both glucose sensitivity and oxidative metabolism, and protects against neurodegeneration. these that perhaps counter what beetroot juice does, or the effects of nitrates and increasing nitric oxide. So it'd be really interesting to see some contrasting studies on performance between, say, beetroot juice and caffeine, or even combining them together to see what the effects are. I mean, I have no idea, but I kind of I'm a very pro caffeine person, not because I love the taste, but there are literally thousands of studies that show how protective it is. So I think that any time you get, I think beetroot juice has only come around in the last 10 years or so, or beets and nitrates, right? And I think if you look at the concept of the degraded system and the response to increasing, and what you can do when you increase nitrates and nitrites and increase these perioxynitrates and cause all these problems, is that they can have the same effects of estrogens and pollutants. And I think that's the thing, is estrogen can increase the production of nitric oxide as well. One of the interesting contrasting effects of methylene blue is that when someone has very kind of low blood pressure, so for example, when you're doing like cardiac reperfusion or cardiac surgeries, what methylene blue does, it inhibits both nitric oxide and another effector molecule, which is guanylate cyclase. And these two effects keep the blood pressure really, really low. And that's what you'll see in kind of sepsis and advanced states where the blood pressure is just tanked right down to bottom, is methylene blue will inhibit that and basically increase the blood pressure and bring it up to normal levels again. So again, here we see another restorative compound having that inhibitory effect of nitric oxide. And I think when it comes to carbon dioxide and stuff, and I've been I did a seminar on pancreas and diabetes recently and looked at some studies from Iran, I think it was, and they were showing that they basically, within their studies, using carbon dioxide foot baths, in 65%, they totally ameliorated diabetic ulcers just by putting people in this foot bath, which created more oxidative tissues, made the tissues much more open to kind of restoring metabolism. I just can't help but wonder what they'd done if they looked at their diet as well, because obviously there might have been a diet or an environmental factor that would push them towards diabetes anyway. But having that 65% total amelioration was quite interesting. So I think the thing is with carbon dioxide, it doesn't cost much, does it? You can come up with aspects of bicarbonate and bag breathing and whatever. It doesn't, you're not going to sell many products from it, but it's probably much fancier to sell a fancy beetroot supplement that's going to cost 10, 20 times as much perhaps, and look for the effects. So I just, when it comes, I've never been one for selling supplements, and I get lots of people contact me saying, "Would I like to do a thing?" I'm not interested in that. It doesn't interest me, because I think you blur the lines as well when you're sometimes selling products and stuff. And that, as much, I have friends who sell supplements, and I'm totally respectful of them because that's their business and stuff, and no problem. But I just I kind of like to look at the stuff without any ties, and I think you can have less bias about stuff.
I do understand, and the little confession we can say, maybe the guys from Cytoled, red light company. Maybe right. You don't. Okay, well, no problem. It's the only it's the only deal that I've accepted after more than 7 or 8 years on things on social media, and it's not a supplement, but it's something to help with the light pattern exposure. So it's different, but still I have a foot inside this, and I still try to suggest that there are other lights that exist and everything. So I do perfectly understand, and just to be transparent, I wanted to mention it here. So yeah. It's really good. I think it's a really healthy way to keep moving in the fitness industry, health world, or whatever you call it, because at the end of the day, we need to understand, and if you want to understand, you want to be the least biased possible. That was just a small thing I wanted to add. So yeah, really cool. About nitric oxide, I think you made an amazing point. I didn't know about this study in Ireland. Do you have it in mind, or you used it like, what was it, a week ago, or was it a month ago, or a little?
Remember the studies. I've got the reference.
No worries.
on somewhere, but I can send them to you. But there's a couple of studies that showed this carbon dioxide footbath.
Okay.
I can't remember that. I can't remember what the study was from, but I've got it on my reference list. I can send that to you.
Oh, yeah, with pleasure. In case you can find it, that would be amazing. So, you mentioned at the very beginning something with hypo and hypercapnia and nitric oxide. Is it systematically going to balance one another, or how does it work? Maybe we can talk a little bit about carbamino, carbon dioxide. How do you call it, bicarbonate, and all these things, and how we have the other option, which is nitric oxide, and how these things are going, because when we talk about acidity, for example, something being acidic, people get really easily confused, and I've heard Ray, not directly, it was a podcast, but Ray talk about the fact that we are not so sure about the way acidity is regulated with bicarbonate and all that, and it may even not work this way. This is I'm not saying this as I'm sure about this. Just I even heard Ray talk about this. So what's your stance right now on all of this and acidity regulation also?
Well, I think even Ray suggested that inside the cell is slightly more acidic anyway.
Yep.
It's designed to be that way. That's why in kind of biological decay and cancer, you tend to see a slight propensity towards like alkalinity within the cell, which is where you get your mitochondrial swelling, calcium being staying in the cell and creating this kind of excitable state. And I think that there are a number of different things. So for example, you can have like respiratory metabolic acidosis or alkalosis. So from a respiratory point of view, that when you hyperventilate, you're usually doing that to buffer an acidity or an excess of carbon dioxide. So you would keep breathing because and this will be usually because there's a relative amount of hypercapnia. Now you can get to the state where you've hyperventilated and then you're in a hypocapnic state. You're in a low carbon dioxide state. So you hyperventilate and then you get to a point where you don't have much carbon dioxide left, and that's when that's where you see a lot of people having panic attacks. You can then take it to a perspective from like you can be vomiting a lot, and you can be passing out a lot of stomach acid, and you can put yourself to a relative state of metabolic alkalinity because you've passed out all of your hydrogen ions. Equally, if you've got lots of diarrhea, because there tends to be a bit more bicarbonate and magnesium in the bowel, if you've had diarrhea as an example, you might end up with slightly more of an acidosis because you've got more of your kind of alkaline type ions. So you can look at it from that perspective. Vomiting can make you vomiting, and hyperventilation can put you in a similar state. And obviously by the time you've got to sorry, my screen's changing different colors here. I'm just going to do that. That puts me off. And then you've got
okay.
Then you've got your diarrhea that's going to put you in a kind of more acidic state. So I think with nitric oxide as an example is that if we think about perhaps going from optimal aerobic metabolism, which you talked about, into glycolysis will put you in this relative state of hypoxia. And hypoxia will usually increase the need for nitric oxide because you want to the attempt of the system is to increase supply to get more oxygen going around just by also relaxing the structures as well, and hopefully getting more oxygen in there. But so what will tend to happen then is that the increase in nitric oxide will increase the stress response. It will break down aerobic metabolism. And also, as I said, it can increase when there's a need for more nitric oxide, you'll get this increased conversion of the nitrate and nitrites, which will also contribute to it. So it can depend on the state from a pH perspective. But generally, as a rule of thumb, when the system does become kind of slightly too acidic, whether it's the blood can become more acidic, then we might need to see that as a response, nitric oxide is being produced. But to an extent, it's a bit like saying, well, is glycolysis helpful? Yes, of course it is. We need to have glycolysis there as a working system. It's there to fall back on in a time of stress. But to the extent that stress is chronic or acute will dictate whether the system can cope with that over a period of time. And that's why we know that people under chronic stress tend to break down, because it's not acceptable from a metabolic perspective, an emotional perspective, or from a regenerative perspective, because you're not given the chance to regenerate in any shape or form.
Yeah, that was super clear. And also this idea again that something that may help during a stressed state is potentially part of the stress state, so it can increase it. So as we mentioned a few times about metabolic flexibility, the ability to go from one substrate to another, we could also look at the ability, the general ability of our system to go from a straight state, but always we need to take into account the ability to go back to a more healthy, more oxidative type of metabolism. And how would you think you can, for example, you talk a lot of time about pulse, temperature, and all these things. When, for example, the temperature is not rising anymore, I heard Ray talk about the fact that sometimes it could be because of an excess of nitric oxide, that the temperature is not rising. But you mentioned that nitric oxide can have an uncoupling effect, if I understood correctly. Or not at all. An uncoupled, how can you découplage, uncoupling effect, sorry. So how would you explain it?
It can affect the aerobic system or the electron transport chain in the same manner that an abundance of polyunsaturated fatty acids can. It can, the same that estrogen can. So all of these things and aspects of pollution, arsenic, hydrocarbons and other things can have an effect on the aerobic system, where the cytochrome C to cytochrome C oxidase and the production of ATP is decreased. So you can get a relative uncoupling. And there are some theories that uncoupling can be useful for longevity, but to the extent that what you essentially do is increase the proton leak, is you basically increase the inefficient production of ATP and you waste glucose. And to the extent that that can be maintained is questionable. And certainly if you've got nitric oxide being in the way, it's going to be a blocking factor. And I might be wrong, but I still believe, and I think there's a lot of things that need to be taken out of, you can look at a bunch of studies and say, actually, your heart rate, when it increases, is associated with increased mortality. Well, unless you're actually looking at who's got functioning biology versus kind of wasting, degrading biology, to the extent that the heart's hypoxic, running off more fatty acids, you're going to see the heart rate increase over time because it becomes metabolically inflexible. If you're someone who's been chronically hypothyroid, who's had a low pulse, and you've got to the extent where you're now in a relative state of chronic hypoxia, then the heart rate is going to start to increase. So you need to take those studies and kind of tease out the effects. And it's the same with thyroid hormone. A lot of people still equate calorific restriction, lowering metabolism, decreasing thyroid hormone is associated with longevity, because primarily what they're saying is, well, a lot of our kind of octogenarians and people older than that have higher TSH levels. But there are some studies that actually show supercentenarians have higher T3 levels. They're generally more mobile, more active. That's only borne out in a couple of studies. But I'm still of the belief that maintaining complex biology, keeping it working at its most efficient form, and that means having good oxidative metabolism, because remember, when we lose oxidative metabolism, that's the pathway for disease, cancers, metabolic disease, inflexibility. So I still think maintaining complexity and function and good structure that's the thing that's going to give us longevity, not going back to calorific restricting, fasting, which can be useful if you're overeating, no doubt, right? If you're kind of overeating and you're kind of too many calories in, that's going to be a useful strategy for you. But I still don't think this concept of fasting and tying it in with kind of low heart rate or low thyroid hormones, for me, it doesn't make sense. And I'm happy to say in however many years' time that I might be wrong, but I'm going to sit on my side of the fence and say that maintaining optimal function is probably where we need to be.
Yeah, and the concept that is probably again brought by Ray, is this link at every level between energy production, function, and structure. And it's true that when you have this in mind, it's really hard to go back and say, for example, palmitate may be a problem because you think about cholesterol, but at the same time it can increase PDH activity, and if you increase PDH activity, you may have overall a pretty positive effect. So and then you have the war on palmitate because suddenly it's a problem, and it's not on a study that is going to be able to talk about this link between energy, function, and structure. So it doesn't mean that it invalidates only to have this concept in mind. It can invalidate results or something, but at least it puts you in a state of with a little bit more humility and thinking about you can only take out of a study what you can take out of it, and you cannot do with what's the name in English, external validity, I think. So you extrapolate a little bit too much the result based on things that cannot really say. For example, again, we talk about cholesterol. This time it's my it's my fault, sorry, but that's also something that need to be considered. So when you keep in mind that nitric oxide is part of something that is not going to help you push the metabolism through oxidative metabolism, you need to be at least cautious about this. Amazing. I think there's not much more that I can bring about nitric oxide. It was maybe the main things I had in mind. You already talked about them, and you added a lot of stuff that I didn't know. So this is amazing from my side. Do you have other things that you think are crucial around nitric oxide, and maybe the way we usually think about this? Maybe something around the gases. Why it's so special, because we talk about the gas this time and not, for example, cortisol. So it's not. You cannot say it's just the equivalent of cortisol, aldosterone, or glucagon, because the state is a little bit different. I don't know anything.
No, I don't have too much to add. I want to say I'm not an expert on nitric oxide. I mean, I kind of tend to look at it in what tends to with failing physiology versus kind of optimal physiology, and I think you see far too many nitric oxide elevations during the chronic stress response. I remember talking to Ray once, and he said, maybe even 1 milligram of methylene blue a day could be pretty good because it lowers nitric oxide. And I think that just keeping the aerobic system maintained in its best working order and minimizing the production of nitric oxide and having it as a fallback, falling back on glycolysis when you need to run after the ice cream truck or last orders at the bar, or whatever, or for your last snowboard lift, whatever it is you do, which would be all of those. So I think we have to look at, that's the thing, is we want to be robust, we want to be able to function, we want to be able to fall back on the stress physiology, but to the extent it's there as a backup and it's not chronically activated. I think you talked a bit like why kind of lactate is being hailed, and you see a lot of people that say like this. There's something called the I think it's the Astrocyte lactate shuttle, which is in the nervous system, where kind of lactate is being used over and recycled. But we know that lactate is pretty inefficient compared to using glucose pyruvate. These mechanisms, and when it just requires that much more recycling. And it's a burden, and to the extent, yes, we want to fall back on that. Yes, during high levels of stress, or perhaps even like some kind of injury, as an example. I think I saw a study where they were trying to say that increased nitric oxide in head trauma was also associated with increased zinc release, and that they tend to pair as well, but that's only when there was significant trauma. And when you get like the hormone response elements, you get these zinc fingers that are kind of binding elements, and that the zinc is given up from that in context with the amount of nitric oxide as well, and together these problems compare. So it's about kind of, when you see perhaps an increase in nitric oxide, you're also seeing other cofactors come in and it'd be a problem as well. So you might see more increased serotonin signaling, you might see more increased adrenal activation. You might see more, favoring gluconeogenesis, more inhibition of glucose use. All of these things need to be taken in context when you're trying to look at what nitric oxide is and does. And I think usually when you're seeing this kind of perpetuation of it, it's usually involved with this chronic stress response. I probably don't have much more to say on it than that. Like I said, I'm not an expert on it, and I've looked at a few studies on nitric oxide and how it tends to be activated. It's certainly not a bad thing to have, but again, it's how long it's being produced for.
Yeah. Oh, okay, I see. I have like 3 small things in my mind. The first one is the difference when you can test the amount of carbon dioxide you produce and the amount of nitric oxide you produce simply by a breathing test, I think, or anyway, there's this link between small intestinal bacteria overgrowth also, because it's going to change the way bacteria also breathe. And the 2 other things is that you use L-arginine for vasodilation. Like bodybuilders, they like to increase the pump, as we say with this. And typically, instead of taking L-arginine, they take the next one, which is citrulline malate. Yeah.
Okay.
And it's something that it's a little bit closer to the ability to produce more nitric oxide, and would help vasodilate and have a good sensation of pump, as they say, when for bodybuilders. I don't think this is like too bad or something, but because the amount is not like crazy, and they take this as a pre-workout. So that was just another thing. And the last one was and this is kind of crazy, because it was during my master degree in the Department of Physiology. They were saying that metformin was basically the best thing on earth, to summarize, and then the best thing for because we in the diabetes department and all that, basically metformin has to be good. And the other thing is that you want to increase. I was looking at capillary density, and when VEGF was increased, they thought it was a good thing, because there's more blood coming, so it must be good. And this is not even a joke. This is like during my master's degree, I saw an increase because the subjects were training for aerobic exercise, and we were looking at the effect of physical activity on glucose regulation and all that. Basically, overall, it was pretty good, but the interpretation of an increase in VEGF, for example, was considered actually a really good thing. So, it gets complicated in research, even if you're directly in a clinical study. It's complicated. That was just a small story, but
I think you see parallels with that. Like, you see many people going, oh yeah, you need to activate the heat shock proteins.
For example,
activate, and it's like you're getting protein misfolding, and some of those heat shock proteins, which I think 70 and 90, I think they are associated with cancer. So why it's always, oh, you need to do this, you need to activate this, you need to bring this up, and it's like there's context to all of those things for sure, right? And even VEGF, it's well known within the metastatic state, right? And cancer. So there's a fine line between increasing and then understanding where the increases can take you over time.
Yeah, of course. But again, it was to say that I was 100% sure as I was doing my master degree, and I was at the time I was really proud of it, to be honest. And I was listening to the guys that were above me simply, and they were just no doubt that an increase in NO, or an increase in or the fact that even metformin can even be a performance drug and enhancing type of thing you can use. And anyway, that was just something I wanted to add. But apart from that, I don't have anything to say about nitric oxide, but we talked about it pretty much 40 minutes. So that's amazing on my side. If you're happy with the video, I'm more than happy with it.
I'm surprised I could talk about nitric oxide for 40 minutes. I've even outdone myself.
Exactly. Okay, perfect. So Yeah, amazing for this one. We're gonna conclude this video for this time. I'm going to translate this in French as well. I'm gonna do my best for this. You talk a lot about all these hormones in your seminars as usual. So if you don't mind, I'm gonna of course put the links. Your website is the easiest way to go to your webinars, or you have direct link?
Yeah, well, there's a seminar page which is just the functional endo
Yep.
or functional hormones page. That'd be great. Appreciate that. Thank you.
Yeah, I have it. That's the least I can do if people want to go further. Because how is it going when you give your seminars? You have like Google Slides or something, and we see your face, and you're talking about, oh, you can interact, or
it's a keynote, so it's
okay.
basically me talking over slides and then just going through the slides and stuff. I kind of, in some of the members areas, there are some old kind of Loom videos which aren't so clear of me talking on it. I just felt that you're hearing me talking,
Yep.
you're seeing the information on the slides. Why I need to see my face, and it's just takes up less kind of volume on the. I mean, the keynotes are still like sometimes 500 megabytes, so it's like I may look at playing around. I'm still. I've had it running a year now, and so it's kind of, and I'm just thinking about where I'm going to take it next and how I kind of take it up a notch.
Okay, so you're still dating this, but it's available right now, so you can go and okay.
Yeah.
Sure.
So there's about 21 seminars up there. There's a couple of rubbish ones that I'm going to take down, which are just old reviews from my master's degree. I'm going to take them down and replace them with some videos. But there's 20 videos and seminars from 15 minutes to 90 minutes in there.
Okay, well, all right. So perfect. I see the link you're talking about, so it's going to be directly there in the description, obviously. So if people are interested, thank you so much. Again, an amazing pleasure, and I'll see you soon. If it's still okay, we have maybe a few others we can talk about, but you will let me know.
Yeah, we can do one.